Hi and welcome to video 2 linear functions. In this video we're going to look at calculating gradients from graphs and coordinates. We'll look at a range of methods for calculating the gradient of a function, and we'll calculate the gradient from some graphs and some coordinates as we go. So first of all, the gradient can be calculated in many different ways, but you might first be interested in case you can't remember, the fact that the gradient is a measure of slope. So if the gradient is positive, it means that our slope is going in this direction. If the gradient is negative, our slope is going in that direction. Positive gradient, negative gradient. And if our gradient is quite large, it means it's quite a steep curve. If our gradient is quite small, then it means it's quite a flat curve. So this might have a gradient of 3, whereas this might have a gradient of 0.5. The larger the gradient, the steeper the slope. And this all relates at this stage to linear functions. So, the gradient can be measured in many different ways. Here they are, or certainly a list of them. The gradient is often said to equal the rise over the run, and I'll explain this one a little bit later. And also the gradient is sometimes said to equal y2 minus y1 over x2 minus x1. And I'll also explain this a bit later, and I'll tell you and show you why this is actually the same as rise over 1. Later on you'll talk about the gradient being the change in y, which we sometimes denote as a triangle, which is the Greek alphabet delta symbol, change in y over the change in x. And again, this is exactly the same as y2 minus y1 over x2 minus x1. But lastly, we can calculate the gradient from a graph, typically using our rise over run, or from coordinates. And then in that case we'll typically use y2 minus y1 over x2 minus x1. The gradient is a measure of the slope, so it's a rate of change. It's a measure, if I draw a quick example of a gradient here, it's a measure of how quickly this graph rises as you pass through each unit on the x-axis. So it's a measure of how quickly the graph is rising per unit, which makes it a rate of change. So let's do some examples. Okay, so to calculate this gradient, there are two ways of doing it. Because it's from a graph, I'm going to show you the graphical method, and then I'm going to talk about what if you knew two coordinates, and I'll repeat that process for a couple other examples. So first of all, the graphical method is the rise over run method. So we draw a triangle. Now this triangle can be anywhere. So we could draw, for example, this triangle, or we could draw this little triangle, or we could even draw this much larger triangle. Basically it's a linear function, so all of your triangles should give the same result. So I'm going to use this triangle here, and I'm going to denote that this is the rise and this is the run. This would always be the case. The rise is obvious, it's the change in y, it's the vertical difference. The run is just another way of saying the distance travelled horizontally. So we have rise over run. In this case the gradient equals the rise over the run. In this case the gradient equals the rise over run, which is equal to 4. Notice it goes from here to here, which is a change of 4 over 2 from here to here, which is a change of 2. So that's equal to 4 over 2, which equals 2. Alternatively, in green, you might choose to just find two coordinates. So let's say we chose this coordinate down here, which is 0, negative 2, and we had this coordinate here, which is 3, 4. We could use these two coordinates to find the gradient using our second method. Gradient equals y2 minus y1 over x2 minus x1. Now, we substitute into this function by denoting that this is our x2, y2, it's our second coordinate, and this is our x1, y1. It doesn't matter which order you do the coordinates in, but if you choose the coordinate that is further along or further up your graph, it will mean that you're more likely to avoid negatives and potential issues arising from negative numbers. So y2 is 4 and y1 is negative 2, so we get 4 minus negative 2. And then we have x2, which is 3, and x1, which is 0, so divided by 3 minus 0, and that of course gives us 4 plus 2 over 3, which is 6 over 3, and that equals 2. So our gradient is 2 in both cases. I'm very happy with that result. Now I'm just going to quickly fly through a couple other examples, because you can slow the video down, stop, relook, etc. So here's my second example. And in this example, first of all, by drawing triangles, I'm going to do the rise over run. So I'm going to choose this triangle. And this time I can see that my rise is 2 and my run is 4. And so I get gradient equals rise over run, which equals 2 over 4, or 0.5 and a half. And I can also do 2 points. Now let's just say I choose these 2 points here, which are the same 2 points I built my triangle with. So I've got 2, 2 and 6, 4. And that means that my gradient is equal to y2, which is 4, minus x2, which is, y1, which is 2, over x2, which is 6, minus x1, which is 2, and that gives me 2 over 4, which is 0.5 again. Notice here that by doing y2 minus y1, I'm actually calculating this number here. So I'm actually doing exactly the same thing, because here's my y2 and here's my y1, and the difference is 2. And here's my x2 and here's my x1, and the difference is 4. So by doing x2 minus x1, I'm actually calculating the length of the base of the triangle, and the length of the height of the triangle is y2 minus y1, and doing exactly the same thing. And now my last example. If I scroll down here, you'll see the last function. Now I just want to make a quick point with this. So to make this point, I'm going to start by just doing my triangle method. If I go down 2 and then along, you'll notice here that I get 2 and 5. So naturally, I would write down that the gradient, which is equal to the rise over the run, is equal to 2 over 5, or 0.4. Now, in actual fact, this graph has a negative gradient. So it's actually got a gradient of negative 2 over 5, or negative 0.4. You can see that because it moves in a downward direction. But also you can see here that whilst this line, the base, is increasing from 0 to 5, this 2 value is decreasing. It's going from 4 to 2. So it's heading in a downwards direction. And that's one way you can treat the rise over run. But this is where I think using the coordinates is far superior. Because if we use these two coordinates, 0, 4 and 5, 2, we get that the gradient is equal to y2 minus y1 over x2 minus x1, which is equal to 2 minus 4 over 5 minus 0, which of course is negative 2 over 5, or negative 0.4. So we get the same answer, but we don't have to worry about whether the gradient is negative or positive. That will come through naturally as long as I put my coordinates in the right order and do x2 and y2 from the same coordinate pair. So that's calculating the gradient by using either y2 minus y1 over x2 minus x1, or by using your triangles on the diagram. Thank you.